Hi, my name is dr. Ahmath. In this video lecture, we are going to start our discussions about vector functions. Well, previously, we defined the vectors which can describe us a line in any dimensional space. So essentially, we used to define the lines using the linear equations y is equal to the kx plus b. Then we found out that it is necessary to develop a new way to describing the line in the higher dimensionalities, and we came up with an idea of describing the points on the line using the vectors, whose ending points are going to be those points on the line. So later on, we define the planes in the same way, where the points on the plane are going to be described using the vectors. In general, we can generalize this idea and describe any curve using the vectors, where the points on the curve are going to be described with some vector, and those vectors are going to have 2 components or 3 components or 4 components depending on the dimensionality of the space. So in general, we are going to describe a curve using the vector equation in the form of a vector where the component of the vector are going to be functions, f of t, g of t, and h of t, where the t is going to be a parameter. And depending on the value of the parameter, we are going to find, or we are going to derive at the different points along this curve. For example, if you just substitute t to be equal to 0, you probably might get this point r of 0. It's going to be a vector which points out to a point on the curve, and when the t is equal to the 1, you might get r of 1, where you're going to obtain another vector which points out to different points. So well, by just changing the values of the t, you can reach different points along this curve. Well, what I want now is I would like to describe the curves which are given by the vector functions. We are going to start with this one. R of t is equal to the 1 plus t for the first component, 2 plus 5t for the second component, minus 1 plus 6t for the third component. So please note that the r of t is going to be a vector. And it's a position vector, and r of t describes the ending point of that vector, right? So all of the position vectors start from the 0, 0, 0 point, and the ending point is going to have the 3 components on the space, on the 3D space, where the x component is going to be equal to the 1 plus t, y component is going to be equal to the 2 plus 5t, and the z component is going to be equal to the minus 1 plus 6t, right? Well, at the same time, I probably can write down this r of t not just like one vector, but the t vector. So I'm going to split this into the t parts. So I'm just going to write 1, 2, and minus 1 plus t, 5t, 6t. So please note that indeed, if you just add these 2 vectors, you're going to obtain exactly this vector. And what I want is, I would like to take out the t from the second vector here. So I'm going to obtain 1, 2, minus 1, plus 1, 5, and 6t. So this is what is r of t. And if you remember, this is very much looks like as an equation, as a vector equation of a line. Right? If you remember, the equation of a line is given as the r of t is equal to the r0 plus v times the t, where we are going to obtain the v, which is going to be parallel to this line with the components 1, 5, and 6. And the r0 is going to be a vector which points out to one of the points along this line, and the r of 0 is going to have the components 1, 2, and minus 1. And what I now have to do is I need to draw a line which is passing through this point and which is parallel to this v, and this is going to be this kind of line. Well, this is how we can sketch the curves which are given as a vector equation. And I would like to do one more example, which is like very beautiful example, where the r of t is going to be given as a cosine of t, sine of t, and t. So please know that you probably remember from the parametric equations that x is equal to this cosine of t and y is equal to the sine if t, where the t is going to change, for example, from 0 to the 2 pi, is going to be, is it a circle, right? So if you just take different values for the t from 0 to the 2 pi, you're going to essentially get all the points along the circle with the radius 1 and at the center 0 and 0. Well, now we're adding one more component t, so for the z component, and now it's going to be a little bit different than circle. So if you just take the different values for the t starting from 0 until like 2 pi, 4 pi, and so on, what you're going to get is something like a spiral. So you're going to get this spiral. So for the t is equal to the 0, you're going to get 0, 0, 0 point here. So this is going to be this point. Sorry, not 0, 0, 0. It's going to be 1, 0, and 0, right? Because cosine of 0 is going to be 1, sine of 0 is 0, and t is equal to the 0. And again, you're going to, after 2 pi, it's going to be here, right? So it's going to be, so if you just substitute t to be equal to the 2 pi, it's going to be 1, 0, and 2 pi. Obviously, the z coordinate of this point is going to be higher. At every 2 pi, you're going to reach this point. So it's going to be 1, 0, 4 pi, and so on. So if you are going to change the values for the t, you're going to obtain the points along this curve. Okay, so this is nothing else. It looks like the double helix of DNA, this curve. So that is why we are going to call this curve as a helix as well. So here we've seen a couple of examples of the vector equations, and at this stage it would be important for us to understand what are differences between the functions and the vector functions. If you remember, we define as a function, we define a function as a map which takes the value, from the set of real numbers and brings you to another set of real numbers, right? So we define the f of x can be equal to x in the square plus 3, where you're going to substitute some value, input 1, and you're going to get 1 output. For example, x is going to be 1 input, 1, and if you just substitute this to here, you're going to obtain f of 1 to be equal to the 4, right? So this type of the function we call is like 1 input, 1 input, 1 output. It's very important. Okay, so whenever you write down, for example, a function on a computer program, you're going to write down a function with 1 argument, and it should give you always an output, and it should always give you an output as just 1 number. So we deal with this kind of functions for all of our courses so far, and now you can guess that there are many different combinations of the number of the inputs and outputs for functions. Your function may have multiple inputs and 1 output, or it may have 1 input and multiple outputs. And that's exactly an example of a vector function. A vector function is an example where you're going to give 1 input, which is going to be a parameter t, right? 1 input. And as an output, it's going to give you multiple outputs. In 2D, it's going to give you 2 numbers, the coordinates of the points along the curve in 2D. In 3D, it's going to give you 3 points, 3 numbers. In 4D, it's going to give you 4 numbers, and so on. F of t, g of t, and h of t. So multiple outputs. Multiple outputs. So conceptually, it's going to be different function than the function which we had so far. Our function so far we had used to be 1 input, 1 output. So now we're dealing with the vector functions, and the main difference, conceptual difference of the vector functions is that it takes always 1 input, which is going to be the value of the parameter, and it gives you multiple outputs. Well, throughout this course, we're going to discuss about the other combinations of the functions, like multiple inputs and 1 output, or multiple inputs and multiple outputs. So, well, in our next video lectures, we're going to discuss about the techniques and tools of calculus applied to the vector functions. I hope that this video was very helpful for you. Thank you very much.